Hey there, Explorer! The following program was brought to you by Team Neutrino in association with the Ames Public Library. Team Neutrino is a FIRST robotics team based out of Story County. We've been helping students build awesome robots for over 10 years. FIRST Robotics offers exciting robotics opportunities for students of all ages, from pre-K all the way through grade 12. Many local elementary schools in Story County offer FIRST Lego League, a program which teaches robotics basics. Lego League is a great way to get involved with robotics and a fantastic STEM activity we hope you participate in this school year. You might even have some fun building Lego robots along the way. Ask a trusted adult or teacher to help you join a team today at www.firstinspires.org. That's www.firstinspires.org. But for now, sit back, relax, grab some popcorn, and enjoy the show!
Hello and welcome back to Full Steam Ahead with Team Neutrino. My name is Basmela and I'm a senior robotics student with Team Neutrino. Over our next few weeks together, we'll be exploring fun and engaging science, technology, engineering, art, and math opportunities that you can enjoy right here in the Story County community. Each episode of our show will highlight unique science fields, explore local opportunities anyone can enjoy, and provide you with fun activities you can do from home. In this episode of Full Steam Ahead, we'll be exploring the field of architecture, which is simply the process of designing and constructing buildings through detailed planning. To start off this episode, I'm standing outside Bircher Hall in central Iowa State campus. Built over 110 years ago, this stunning work of architecture is home to some of the most important people at Iowa State University. Bircher Hall is an example of neoclassical architecture. This means that it was inspired by classical Roman architecture, which usually involves massive stone pillars. This building is a beautiful and functional example of how artistic design and structural engineering work together. Today, we'll learn about what goes into actually designing buildings like this, and it all starts at the Student Innovation Center. Let's head over. We're here at the Student Innovation Center over in West Iowa State campus to see what we can learn. The state-of-the-art Student Innovation Center has something for everyone, from the architecture lab to apparel design lab to the culinary creations. This STEM Center provides unique equipment and resources for all students on campus. There's always a creative space or displays to give you ideas, no matter your field of science. When an architect is designing a building, they first need to consider the space they have. Oftentimes, buildings are limited by how much space there is to build them. Sometimes this means getting creative about the shape of the building or how the space can be used for more than one thing. This is why it's important to know the purpose of a building before you start planning. As you might know, buildings have both an interior and exterior. An interior is everything inside the building, and an exterior is everything on the outside. Although they both have very different purposes, they're both very important. Without a nice interior, people wouldn't feel comfortable, and without a nice exterior, the building would not withstand bad weather. Architects consider both parts of a building when they're planning. Next, architects make detailed drawings of the building. This means they sketch everything from how many floors the buildings will have to what the exterior will look like. If you've ever heard the phrase measure twice, cut once, this means architects plan every inch of their building in great detail before they even think of constructing it, so that they do not make any mistakes. Buildings are designed to be both beautiful and strong. Architects utilize old and modern designs and techniques to make buildings look as appealing as possible, and they work hard to make buildings structurally sound. This means they're safe and support all the weight and stress created by everything, from wear and tear to severe winds. Above all, safety is the top priority when designing anything people use, like buildings. Finally, the architect calculates what materials should be used that are strong enough to support the building so it can stand for many years. After the plans are completed, now it's time to build it. To learn more about the construction process, let's head upstairs. Today we'll be exploring the architecture robotics lab. From 3D printing to structural design, this is a great place for us to not only learn about how buildings are made, but also about the techniques engineers use to make them. You Shelby Doyle, the Associate Professor of Architecture. Hi, I'm really glad you could this today.
Thanks for being here and thanks for your interest. This is the Architectural Robotics Lab at the Student Innovation Center at Iowa State University. And so what you'll see here are some examples of some of the work that we've been doing, looking at 3D printing plastic, 3D printing concrete, and then also looking at 3D printing reinforcement for concrete, using non-traditional materials as a way to reduce concrete use and to think about how we might fabricate lighter structures. So these are examples of things like, here we have a mold that was printed out of a water-soluble plastic, and this is made out of the same sort of plastic that it goes into your laundry detergent pods. It's the same water-soluble plastic that coats that, or dishwasher pods. It's also the same plastic that goes into glue sticks. So when you're making crafts in class, that's what this would be. And so the way that works is that we might do something like print reinforcement at the same time as we print that water-soluble plastic, and then we would pour into that mold and then put the entire thing in water, and it would dissolve away and only leave the concrete. So that's an example of something we've been doing. We've also been looking at ways that you can build hybrids between standard construction and robotic construction, and then looking at ways to prototype construction at smaller scales with these 10-in-1 off-the-shelf robots that you could program with your phone, so that students can quickly think about ways that they could design with robotics in a construction scenario. So there's some examples. We've done things like have workshops where we taught robots how to paint or how to draw. And a lot of what we do is think of ways that robotics can be creative and move outside of the industrial space where they typically are used for things like fabricating cars. So the Cooper industrial robotic arms that you see here are the same types of robotic arms that you'd see in a factory that would be assembling an automobile. And so they're typically used to do one thing over and over and over again for the lifespan of the robotic arm. And we do things a little differently here, where we might be running unique code and new design ideas every single time that we run the arm. This part here would go on the end of the robotic arm, and basically this is a pneumatic actuated gripper. So that means that air goes into the gripper here and opens and closes it. And so we've 3D printed here a prototype of a gripper that picks up and moves rebar so that it can be placed on site. And so this part was 3D printed, this part was milled in aluminum, and this part's off the shelf. And then we milled a custom piece here in aluminum so that it could actually attach to the robotic arm. So if we come over here, what would happen, sorry, this is all messed up, but is this piece would be put here, and then you would be able to communicate with the robot to pick up and move a piece of rebar. So on this, we have designed, again, another 3D printed piece that's going to attach onto the robot here. And that lets us take an off-the-shelf 3D printer. So this is an off-the-shelf 3D printer head. And attach it by just sliding it into this, onto the end of the robotic arm, and then that's how we would 3D print something like this. So that head would move around and deposit plastic in layers until it came all the way up to this side. One of the questions we get a lot is, what do robots have to do with architecture? And so part of the way that we're thinking about that is that we're thinking of ways that you could build with robotics. And so in this example here, a series of architecture students who are fourth years at Iowa State in the College of Design are thinking about designing accessory dwelling units. So this means that you would have a separate house in your backyard where maybe your grandmother lives, or an older brother and sister, or an uncle or an aunt, so that you can keep an intergenerational family on one property. And so this is an example of a giant 3D printer that's coming around, and the students have been designing houses that would be printed in situations here out of concrete. And so that's how we're bringing together ideas of robotics and design and construction. And so this is a model of a neighborhood in Des Moines, and it's still in process, but you can see things like here we have a concrete mixing truck that has come to the site so that they can use this giant 3D printer to 3D print a house out of concrete. And so this is an area in northeast Des Moines near the Capitol, and you can see that we're looking at ways that you might get construction equipment into a neighborhood, and then eventually there'll be about 24 different house designs on this site. So another question that I get a lot is, what else can you do with these technologies? And this is a Dremel 3D printer, which prints different plastics by heating it up, and you put a 3D model in and it prints the 3D model. And so one of the things we were able to do during the COVID-19 pandemic is print face shields for hospital workers in Iowa in a partnership with Alliant Energy. So you'll see here that these parts of the face shield were printed on these printers that are right here. So you can see the printer running and going ahead and laying down material. So I think that some of the skills that we're talking about and the attitudes about design allow us to do work that we might not otherwise be able to do.
Now that we've explored the robotics lab, let's head to the studio where we can check out today's craft. Welcome to a segment we're calling Stay-at-Home STEAM Activities. We're here at the Iowa State Extension Video Studio to share with you fun and engaging science, technology, engineering, art, and math activities and experiments that you can try safely in your very own home. Today, I'm joined by Amelia.
Woo!
Amelia will be helping me explain today's fun activity, so go ahead and grab a trusted adult and let's get started. Today, we'll be designing our own building. To do this, we'll explore what shapes are commonly used in architecture and compete to design the strongest tower. You'll need a ruler, a bag of marshmallows, a package of toothpicks, smaller marshmallows, some note cards, and 2 toys that are not too heavy. Now let's get started. Let's start by measuring our tower. For this challenge, we want the tower to be 1 foot or 12 inches above the building surface. The goal is for the tower to be able to support your toy. So like an architect, let's explore the different ways we can solve this challenge. To do this, we'll try 2 different methods. Amelia here will help me design 2 different towers. A tower using squares and a tower using triangles. They each need to achieve the same goal. So let's see if we can see which shape is stronger. To make a tower, we'll take several layers. To do this, we'll push the toothpicks into the marshmallows to form patterns. As you can see, the tower fell when we used squares. Now let's see what happens when we use triangles. We'll talk about why the triangle tower could support the toy car, but not the square one when we return.
We will be right back.
Did you know? Before an architect can even start thinking about constructing a building, they first need to draw up a set of very detailed plans for the building called blueprints. Blueprints detail everything from how many walls a building will have to how tall it will be. This is to be sure there aren't any mistakes during construction because workers have detailed plans to follow. Measure twice, cut once.
Welcome back to Full Steam Ahead with Team Neutrino, brought to you in partnership with the Ames Public Library. My name is Basmela, and I'm here at the Ames Public Library to showcase the incredibly fun science, technology, engineering, art, and math books you can find here. Today we'll be looking at one of my personal favorites. Built to Last by David Macaulay is a fascinating look at why some of the coolest buildings on Earth are so strong. From ancient structures to medieval castles, this book features fun, detailed insights into how architects design and construct amazing buildings. You can enjoy Built to Last today right here at the Ames Public Library, along with thousands of other educational titles and fun weekly events that you and your whole family can enjoy. Now back to the show. Before the break for our stay-at-home STEAM activity, we designed 2 marshmallow towers, one with a square pattern and one with a triangle pattern.
Let's get back to it.
As you saw before the break, the triangle towers took for longer, and this is because the triangle supports are the strongest, and therefore the most common in architecture. If you've ever seen an architect call a truss, you know what I'm talking about. A truss is a triangle support you might see in many rooftops and houses. Trusses are simply triangles, which provide the most support to a building. Beyond shape, there are countless other variables to try out. Is your tower stronger with a wide base or a narrow base? What kind of surface works best? You can keep experimenting at home in all sorts of other ways to keep learning about how architects can make buildings better. If you enjoyed this stay-at-home STEAM activity, you can find more simple and engaging tutorials online. Visit www.youtube.com/teamneutrino for nearly 2 hours of free stay-at-home STEAM activities, like do-it-yourself elephant toothpaste. You're bound to find something fun you can do. So what are you waiting for? See you later!
Did you know? Ancient Roman architecture heavily inspired how we design buildings today. In fact, nearly every building you've ever been in was made possible by thousands of years of Roman craftsmanship. Their strong design choices have set the standard for how we make buildings safe and beautiful in modern times. In fact, the Roman Pantheon is still the largest freestanding concrete dome ever built. Hopefully, it'll be standing for years to come.
Thank you for joining us on this episode of Full Steam Ahead with Team Neutrino. In this episode, we learned about architecture, from the design process to manufacturing techniques. We also explored the Student Innovation Center, a fun place here at the Iowa State University that you can explore with a trusted adult. Make sure to join us next week as we explore astronomy in our local community. See you there!
Thank you for watching Full Steam Ahead with Team Neutrino. We hope our show inspires you to continue to innovate and design while enjoying the fantastic and fun opportunities Story County has to offer. See you next time!